Hey guys, welcome back to our second lecture of number systems, and we are going to continue from where we left off. So, as I said in the previous lecture, these are the topics where you need this as a core foundation. So, make sure you pay attention to this solutions and shortcuts so you can, you know, solve the questions based on these much faster. Now, if I remember correctly, many of you might have struggled with the few calculations in the past lecture. Like, so multiplication and division is a basic challenge for many students, you might not be knowing, but if you are not one of them, obviously you won't know. But for many, it is a challenge. So I would recommend that at least from 1 to 20 tables, multiplication tables, you must mug them up. I'm not saying you have to remember them. I'm literally saying you have to mug them up like crazy. Even if at midnight 2 a.m. someone asks, hey, wake up, what is the multiplication of 18 points in 18 into 7? You must know what is the answer. That's the level of, remembrance you need to have for these things. And apart from them, there are also squares up to 35 and cubes up to 25. The squares and cubes, these are very important because very sequences, series type question are dependent on this. And of course, for various quantities, if you know that this is the square of number, you will realize, okay, the calculation might be dependent on this square value. I will have to find the root somewhere. So in that case, it is very helpful to know beforehand that this number is a square or cube of some other number. So you will have to remember at least this much. And of course, I know it is not easy to mug up such things. So I would recommend take a printout of like 3 papers. One would include table from 1 to 20, like, and other would for squares and cubes, and stick them to your study desk. So at least each day you will see, okay, this is 1 to 20 table and cubes and squares values. Now, if I remember correctly, in last lecture I had given you some homework. Better give me answers. Uh, and of course, I expect many of you might have solved them yourself, but let's just cross verify what are the answers. And this is how we do it. I took the first unique number, that would be 13, subtracted the non-repeating term, that is 1, and divided by r times 9. I think, yeah, that would be more correct. So 13 minus 1 divided by 9, and you can evaluate it like 4 by 3. I think that was easy one. And you can also think of it like this. If you know 0.3333 is 1/3 and you have just added a 1, then 1 and 1/3, that would, if you solve it like 1 and 1 by 3, if you solve it, you will again get 4 by 3 directly. So you don't even need to go through all this calculation if you know some basic fractions like that, like 0.666 would be 2 by 3, etc. Then coming to the next one, this was a bit more calculation intensive, if I must say. This is the basic unique number, non-repeating one was 454332, and the completely non-repeating term was 454 in that, and there were 3 repeating terms. So I got 999 at the bottom, 0 for the non-repeating terms after the decimal. And after solving, you can get this value. Now comes the fun part. Oh, there is one more, sorry. And you might have tried this, but sadly it is an irrational number. So if you didn't pay attention to the last lecture, unfortunately you should go and check it again, because there is no repeating pattern in this number.
Hello, sir. Borobot here. Sir, but after the decimal point, isn't there a sequence of odd numbers? That means we are definitely sure about what the numbers are going to be. So how can it be a irrational number, sir? Because we know what the numbers are after the decimal and they are not indefinite, right?
Yeah, some of you might argue that 1, 3, 5, 7, 9, 11, 13. And next would come 15, then 17, then 19, right? These are all odd numbers, I also know. But is there a repeating pattern? There is no repeating sequence. Of course, there is a pattern. They are odd numbers, but there is no repeating sequence. There has to be a repeating sequence for it to be counted as rational after the decimal values. So, unfortunately, if you try to solve it thinking that there is a pattern, so it might be rational, sorry, but you need to get your understanding again because there has to be repeat sequence. Now, coming to the next term, pi. Unfortunately for you guys who might have written 22 by 7, it's wrong because pi is an irrational number. 22 by 7 is only an approximate value, it is not the correct value. So if you think pi is equal to 20 by 7, 22 by 7, it is false. You should remember it is only approximately equal to 22 by 7, not exactly equal, because pi is always represented in these two ways. Not never ever has anyone indicated pi is equal to. If you read some proper books for mathematics or something, you will always notice pi is never written as equal to. It is always like this curly equal or some equal with curly one line. This indicates it is approximate or close rounded off value. And why is the reason that? Because if you calculate the value for pi, it will go like 3.141592 and so on. And 22 by 7, it will go like 3.14, 28, 57 like that. So only the first two digits after the decimal are same. That's why we take it as an approximate value for to make our calculations easier. So, but it does not mean that it is exactly equal to 22 by 7, and hence you should also remember that pi is an irrational number. That's why in many scientific calculators they give pi as a separate value. Otherwise, you can easily always just multiply 3.14 or 22 by 7 for any calculation you want. But for exact value, there is a separate pi number given in scientific calculators. Okay, keep that in mind. So with that said, let's do a bit of practice sets based to check whether your concept of the number tree is correct or not. So here is our fourth question for this series. Of course, I will be counting these questions as well. For you, I expect that you are also counting how many types of questions you are doing. So this is the question. Let's say we have two irrational numbers m and n. Then I want to know that m plus n minus the multiplication of these two is always going to be what kind of number. Either it is going to be imaginary, irrational, rational, or we can't say anything about it. So you can take a, this is a video, so obviously you can pause and try the set, and after that you can verify your answer. So go ahead and pause and try it yourself. And I will also show how I would do it if it were to come in exam. Of course, it won't be coming in any exam except for SNAP or some other aptitude exams. So here it is. Let's say m is a irrational number and that is given. So I will take root 2 and n should be, let's say, root 5. Now I will try to solve it as per the formula root 2 plus root 5 minus minus multiplication of these two. I will be getting this value root 2 root 5 minus root 10, and of course it is an irrational number as we cannot make any simplification of it or any sense of this. But let's try a few other values. We cannot be sure that it is always going to be irrational just from this one example, right? So let's take let's keep m as 2 itself, and let's take n as a minus of root 2 this time. And mind well, this is not under root of minus 2, otherwise that will be imaginary number. I am writing n equal to minus of root 2, not root and then minus is not inside, mind well. So root 2 is solvable and minus is outside. Okay. And again I will do the same operation, but this time around I will be getting this value. Root 2 and root 2 will cancel each other out, and the multiplication will return 4 as our final value, which can be solved for 2. So this time we got a rational number, right? So based on what the value of m and n can be, the final solution will always be different. So obviously we cannot say for surety what it's going to be. That's why this is going to be option D. This example is just basic for showing you that you should not stop after just one example. You should take a different criteria. Many of you might have not thought about taking a negative root value. That's why I specifically chose this question. Moving on to next question. Let's take this value as example. I have a number 8 raised to 1.333 and so on, and it is a rational number. So is this statement true or false? You can try to solve it yourself. Just pause the video. Go ahead. Now, we all know 1.33 can be expressed as 1 plus 0.33. So we'll get 4 by 3, which we have solved earlier in the first example. And if I write this as 8 raised to 4 by 3, I can just simplify it like cube root of 8 raised to 4. And we all know cube root of 8 will be 2 and 2 raised to 4 will be 16. So yeah, it is solvable, and of course it's a rational number, so our statement is true. Moving on to next question. I'm sure you guys would be loving this, so a like to the channel would be very rational decision for you. I'm sure that didn't come out great. Anyways, let's go to the next question. Out of the following values, which is the greatest? We have root of 5 and cube root of 9. 5 we already know that it lies between 4 and 9, which are the squares of 2 and 3. So root 5 definitely lies between 2 and 3. That is the first common logic that went through my head when I saw this question. So root 5 would definitely be 2 point something, correct? Similarly for 9 we can say it lies between 8 and 27, which are cube roots of 2 and 3. So it will again be 2 point something. So just by this logic we cannot directly solve it, but we can try a different approach now. That would be, we will try to solve it obviously. Root 5 we can express it like this, like 5 raised to 1 and 2, 1 by 2 and 9 raised to 1 by 3. Now let's try to remove these powers. How can we do that? Like this. To make them, we have to compare these two values, right? So we'll try to, bring them to the same level, to the level playing field. So what we will do, we will apply power of 6 to both of these numbers. By doing that, what will happen? You may be wondering, let's say I have any two number. Forget about these two number for now and think of any random number, A and B. If you are applying the same power, whatever number you take, if you are applying the same power to both of them, the final result will also have the same relation. That's why we are trying to bring them to the same level by adding the power of 6. At least for real positive numbers. I haven't tried this for negative numbers. Perhaps you could try it. Now, if we add power of 6, we will get 5 raised to 3 and 9 raised to 2. Now you can see very clearly which is the greater value, right? 125 is greater than 81. So our final answer would be root 5 is greater than cube root of 9.
Hello sir, Kelvin this side. So I understood the solution, but is there any specific reason why we took 6 for applying the power, sir? Is there any specific reason for selecting that number?
Obviously, many of you might be wondering why we had taken 6. Well, because if we solved for 5 and 9, you can see the powers are 1 by 2 and 1 by 3. So the LCM of 2 and 3 is 6. That's why we took 6, because it will make it a normal power, easy for us to evaluate. Let's say I had taken 4. Then of course I could have gotten 5 square. But what about 9? I would be stuck with 9 raised to 4 by 3. I cannot solve that. Not at least without calculator. So this approach is very useful when you just want to compare two different values on the go. So with this clear, I hope you guys are enjoying this and doing a fantastic job. In such a case, the sub to the channel would be marvelous. So let's move to the next topic or next question we can say. And this one should have a higher bit of language if you are not quite familiar with vocabulary in English. You should try this to understand yourself. I have three numbers j, k and l which are consecutive integers, and I have written a few statements here, and you have to find which one of these statements will always be true. Mine will, the condition is these four, out of these four, which condition will always be true for three consecutive integers. So go ahead, if you are confident you can do it, pause the video and try it yourself, and I will be trying it myself here to demonstrate how I should go about it. So first of all, what can the three consecutive integers that come to mind? It can be 1 2 3 3 4 5 7 8 9, any number, right? But you have to think from a broader aspect. It has said integers, not just positive integers, right? So there can be 0, there can be negative. So your set should include all of them. Mind well, your set which you are taking, for example, you should consider negatives, whole number and everything. With that said, now we have two scenarios. First, either it would be odd, even and odd, or even plus odd plus even. Only these two possibilities are there, right? If we take any three consecutive numbers, any one can happen. So what I can conclude from this, if the middle term is always even, then the sum will always be even, because odd and odd will cancel each other out. So it doesn't matter whether the side terms or the extreme terms are odd or even. What is the deciding factor is the middle term. So my goal is to determine this middle value, and there is only one way for which I am sure this middle value will always be even. What is that? By multiplying it by 2. That will be this condition, our C. So whenever I am multiplying the middle term by 2, it doesn't matter if the extreme terms are odd or even, they will cancel each other out. But the middle term, that will always be even, and so my final value will also be even. So with that said, I hope you guys understood today's concepts and you would be getting quite acquainted with the number system. And I would like to what I said, just like I said, you need to mug up some values, right? So I would try to share this for you. You can just print it out and stick to your study board or wherever you are suitable with. But I don't know whether it clicked for you or not, but for me it definitely clicked when I saw the squares table together like this. That's why you need to have a certain observation skill. Have you ever noticed that whenever you go about from this value to the outside, there is a certain difference which occurs. Let's take here, if I go from 25 to back, 16 and 36, let's compare them. What is the difference of these two value? If you might be able to answer in comments, 20, right? Similarly, if I subtract 49 and 9, that would be 40. Again, 64 and 4, that would be 60. So what we notice, as we are going from the center to far, it is a difference of 20, multiples in the difference of 20. Like first was 20, 40, 60 and so on. And the fun fact is, it can continue even further. Let's take 15 square, for example, 225, 256 and 196. If you find the difference, it will be 60. Similarly, in 25 table you can try 625. Below it is 676 and 576. Now this is the most easy thing you could do. It is directly a difference in the multiples of 100. Here it is 100, then it goes to 200, then 300 and so on. And the best part, let's say I go here 400. How many steps is 20 away from 25? 5. And how much is 30 away? 5. So 100 into 5, that will be 500. The difference is maintained. The difference between these two is 500. That is maintained. Again, let's go even further. 961 and 361. 600 difference. 1024 and 324. 700 difference. So if you manage to somehow remember till 25, the squares up to 25, you can keep making this sequence on and on. And even funny thing, if you have noticed or not, this difference in the tens column, in this one column, is increasing by 40 each time I go up. This pattern will also be following, right? This value will also be increasing by 40. But if you take 25 as a base, then you can go up to 50 also. And for 50 itself, there would be a separate value. From there, you can also find till 100, right? So I think for squares, at least if you remember till 25, it will be very good for you, because by this trick, I'm sure you can make up the next values also. And for cubes, I think you should try it yourself if there is any pattern or not. With that said, let's meet again in the next lecture. Thank you.